Yes, please do. Okay. Hello, everyone. Welcome to a new session of the ISCB Student Council webinars. Today we have with us Tanzina Akhtar from University of Chittagong in Bangladesh, and he will tell us about research using curcumin against Salmonella Typhi. Thank you for being with us today, Tanzina. You can start.
Thank you. This is Tanzina Akhtar. Currently, I'm studying at University of Chittagong, Department of Genetic Engineering and Biotechnology, Bangladesh. This is my very first work, Curcumin against Beta-lactamase and LD Transpeptidase in Salmonella Typhi. And I feel very honored to present my work here. Now, Salmonella typhi causes typhoid fever, which is an acute illness related to fever and primarily transmitted by fecal oral route and can infect the intestinal tract and blood. An estimated 12 to 27 million people are affected by typhoid fever globally each year, whereas the overall estimated incidence is between 292 to 395 cases per 1 lakh people per year in Bangladesh. In Bangladesh, 113 frozen chicken meat samples carried extended spectrum beta-lactamase resistant salmonella from super shops available in 5 divisional megacities was found in recent studies, which was very dangerous. In Bangladesh, ciprofloxacin resistant strains was very common. And besides, resistant to beta-lactam antibiotics is found to 50.28% of isolates, and the resistant gene is Beta-lactam. And Bangladeshi scientists found that this gene, that 89.16% of the strain carried that gene, which is responsible for the resistance to ampicillin. And this chart shows that the typhoid and paratyphoid fevers fevers occurred among the female and male individuals. This is showed that the gene BLATM1B produce the beta-lactamase enzyme, and that enzyme hydrolase the beta-lactam chain, and it produce substituted amino acid, which is responsible for antibiotic resistant, specifically beta-lactam antibiotic resistant. An interesting thing is, for the secretion of typhoid toxin, which causes typhoid fever, like cholera secrete one kind of toxin, Shigella secrete Shiga toxin. Salmonella typhi also can secrete a typhoid toxin. And for this secretion of typhoid toxin, LD transpeptidase is an enzyme which is very necessary. And for this, the toxin producing cell produce in a cell in this bacteria, and then this toxin through the sec machinery pass into the inner membrane, where peptidoglycan stay, and then it formed into holotoxin, and then this holotoxin translocate into the trans site, and it mediated by the TTSA, which is a gene. It is an enzyme, but the secretion is mainly occurred by early transpeptidase. Here, early transpeptidase is very necessary for typhoid toxin secretion. And this typhoid toxin secretes into Salmonella typhi containing vacuole. So we can say for typhoid fever or typhoid, typhoid toxin is very necessary. This is the methodology of my work. At first, we did literature review, then we identified the genes, then protein identified from NCBI, then primary structure predicted by protoparam, secondary structure prediction, homology modeling was done by then model validated by Procheck, and active site prediction by Coach, and post at last post screening method was done, and then four ligands were selected. This is the result of primary structures of protein. Here this chart shows the number of amino acid of beta-lactamase and L-transpeptidase, molecular weight, and theoretical pi, instability index, aliphatic index, gravy. We can see beta-lactamase is more stable than L-transpeptidase, as it is up to 43, greater than 40. Then L-transpeptidase is high molecular weight and is high theoretical pi, etc. And this is the result of secondary structures of protein. Uh, Here alpha helix, pi helix, beta bridge, beta turn, and other etc. things. This is the result of homology modeling. Both of the protein are monomer. Biunit oligosaccharide is monomer, and the method was and for the beta lactamase 1.55 angstrom, and for L-transpeptidase 2.76 angstrom. This is the result of model validation, which was done by Procheck. Verified 3D was passed, and both of the proteins, beta lactamase and L transpeptidase, peptidases residues, most of the amino acids residues was in favored region, which means the value, which indicate the validity of the these proteins. And this chart shows the number of glycine residues, number of proline residues, etc. And then this figure shows the beta lactamase. Mainly the A figure shows that the primary structure, the secondary structure of beta lactamase. B figure shows that the gene causing region of the beta lactamase enzyme. C shows that the Ramachandran plot. D means the 3D structure of beta lactamase. E means that uh, uh, the secondary structure of beta lactamase, which is done by the and the F shows the uh, active site prediction of beta lactamase, which was done by Coach software. And this is also of the LD transpeptidase result. A shows that A indicate the result of secondary structure, B indicate the result of gene causing region prediction, C indicate the result of Ramachandran plot, and D indicate the 3D structure prediction, and E indicate the secondary structure, and F indicate the active set prediction. Now we can see the beta-lactamase plus cyclovalone. Here we can see in the first figure, we can see the ligand on the pocket of the protein, and then protein ligand interaction, and then the secondary structure of cyclovalone. Then we can see the LD transpeptidase plus cyclovalone. Then we can see the protein ligand interaction. That means the LD transpeptidase plus cyclovalone, and then the the secondary structure. In the first two figures, that means the cyclovalone in the pocket of the beta-lactamase, and in the pocket of the LD transpeptidase enzyme. And in the second figure, the interaction between the cyclovalone with the beta-lactamase and the LD transpeptidase. Now we can say curcumin contains so many nutrient or so many ingredients or so many compounds which is antiviral, antimicrobacterial or anti-inflammatory, and which is good for our health. And this is curcumin longa, which scientific name is curcumin longa. Thank you.
Thank you so much, Kansina, for your presentation. We can wait a few moments to see if there are questions. And I have a question. Because you perform these tests with cyclovalone, and as far as I know, this is a synthetic compound, similar to or derived from curcumin. So natural curcumin has a similar interaction, do you know, or is only this compound?
Sorry, can you please ask me again?
Yeah, the question is that as far as I know, cyclovalone, that is the molecule you tested, is synthetic and is derived from curcumin. So my question is if you know if natural curcumin can interact in the same way with these proteins.
Actually, we did a computational or bioinformatics examination, or we can say computational. We use computational tools, and we predicted everything, and the result is also predicted result, and we can say the predicted result based on the tools. And actually I can't understand your question properly. I'm so sorry.
Okay, don't worry. So there are no more questions. Thank you again for your presentation. It was very interesting. And thank you to the people watching this webinar. Have a nice day.
You're most welcome.